Imagine waking up tomorrow and discovering that almost every artificial intelligence system on Earth has stopped working. ChatGPT, Gemini, Claude, Midjourney, autonomous cars, robots, medical research. Everything slows down because of a single company. It sounds impossible, but that company exists. And what makes this story even more fascinating is that it was never created to build artificial intelligence. For decades, it was known only for making graphics cards for gamers. Today, it is worth trillions of dollars and controls the infrastructure behind the greatest technological revolution in human history. This is the story of how NVIDIA built the empire of artificial intelligence. Go back to 1993. The internet was still taking its first steps. Smartphones did not exist. Google had not been created yet. Amazon was just an idea. At that time, 3 engineers gathered in a small restaurant in Silicon Valley to discuss a bet that almost nobody believed in. They believed the future of computing would not be built around traditional processors. Instead, they believed it would depend on a new form of parallel processing. It was such a risky idea that many investors did not even understand what they were trying to create. One of those engineers was Jensen Huang. Unlike many CEOs in Silicon Valley, he was never interested in fame. His focus was different. He wanted to build technology so advanced that competitors would need decades to catch up. While other companies were focused on winning the battles of that year, Huang was making decisions based on what the world would need 20 years later. That ability to think decades ahead would become NVIDIA's greatest competitive advantage. During the 1990s, video games were evolving at incredible speed. Every new generation demanded more realistic graphics, larger worlds, and increasingly complex visual effects. But there was a problem. Traditional processors simply could not keep up. They had too many calculations to perform at the same time. It was like trying to build a skyscraper with only one person doing all the work. Then came a simple question. What if, instead of having one extremely powerful processor, thousands of smaller processing units could work together simultaneously? Instead of completing one task after another, they could divide the workload and solve everything in parallel. This architecture gave birth to modern GPUs. At the time, it seemed like nothing more than a solution for improving video game graphics. In reality, it was the first step toward modern artificial intelligence. Creating a new architecture was only part of the challenge. The real problem was convincing manufacturers, developers, and investors that the idea actually made sense. NVIDIA was still a small company with no guarantee of success. One failed product could have ended the company before it ever became relevant. In 1999, NVIDIA introduced the GeForce 256. Many consider it the first modern GPU in history. It delivered a massive performance leap for gaming, but hidden inside that chip was something almost nobody noticed. Its true importance was not about graphics. For years, NVIDIA was viewed only as a graphics card company. Meanwhile, behind the scenes, it was quietly investing billions of dollars into research, software, and computing architecture. The market believed NVIDIA was selling hardware. Jensen Huang was building an entire platform. In 2006, the company made a decision many people considered a waste of money. It launched CUDA, a platform that allowed developers to use GPUs for almost any type of computational task. At that moment, almost nobody used it. It was not a flashy product. It was not a new chip. It did not generate headlines. To many investors, it looked like a project without a market. But Jensen Huang saw something others ignored. One day, software would become just as important as hardware. If GPUs were the engine, CUDA would be the language that allowed people to unlock all that power. Without CUDA, NVIDIA's chips would remain just extremely powerful graphics cards. Developing CUDA required years of work and hundreds of millions of dollars. For a long time, almost nobody used the platform. Analysts questioned the investment. Many believed NVIDIA was wasting resources on technology that had no real purpose. But Huang was never running the company based on the next quarter. He was building an advantage that would only become visible years later. At that time, artificial intelligence was still a small academic field. Researchers trained tiny models, computers were slow, the cost of computation was enormous. Most people believed useful AI applications were still decades away. But every revolution begins the same way: small, slow, and ignored. Then, something unexpected happened. Researchers started replacing traditional CPUs with GPUs in scientific experiments. The results were astonishing. Simulations that once took days could now be completed in just a few hours. The improvement was not 20% or 30%. In some cases, the performance increase was dozens of times faster. For the first time, people realized that these chips could do much more than render graphics. Little by little, universities around the world began adopting CUDA. Not because NVIDIA launched massive marketing campaigns, not because it was aggressively promoted, but because researchers themselves were sharing their discoveries. Every new scientific paper reinforced the same conclusion: GPUs were the best option for parallel computing. The community was growing quietly, without Wall Street understanding what was happening. Then came 2012, one of the most important moments in the history of artificial intelligence. A group of researchers presented a model called AlexNet in an international image recognition competition. The results were so far ahead of the competition that many people believed there was a mistake in the numbers. But there was no mistake. There were NVIDIA GPUs training that neural network. After AlexNet, everything changed. Companies that had previously ignored artificial intelligence started investing billions of dollars into research. Google, Microsoft, Amazon, Meta. A new technological race had begun. But there was one problem. Every company needed the exact same thing: computing power. At that moment, NVIDIA had an advantage that nobody could quickly replicate. It was not just selling chips. It had the hardware, the software, the developer tools, and an ecosystem that had been built over more than a decade. Competitors could manufacture processors, but recreating the entire ecosystem would be much harder. Major companies started purchasing thousands of GPUs at once. For the first time, NVIDIA stopped being just a supplier for gamers. It became a strategic company powering the infrastructure of the internet. The artificial intelligence race had officially begun. But NVIDIA's biggest growth was still ahead. While companies were quietly investing in AI, a small artificial intelligence laboratory was working on a project that would bring this technology to hundreds of millions of people. When that project launched, the world would never be the same again. On November 30th, 2022, a small artificial intelligence laboratory released a product called ChatGPT. There was no massive event, no giant stage, no worldwide announcement, just a simple website where anyone could have a conversation with an artificial intelligence system. At first, it looked like just another experiment, but within days, millions of people started using it. For the first time, artificial intelligence left research laboratories and reached ordinary people around the world. Every question sent to ChatGPT needed to be processed instantly. Now multiply that by millions of users, then hundreds of millions. The infrastructure required to answer all those requests was enormous, and hidden inside those data centers were thousands of NVIDIA GPUs working continuously, 24 hours a day, 7 days a week. When people think about artificial intelligence, they usually imagine advanced algorithms or intelligent interfaces. But there is an invisible layer that makes all of it possible: computational power. Models like ChatGPT need to perform billions of mathematical operations to generate a single response. And this type of workload is exactly what NVIDIA GPUs are designed to handle better than almost any other hardware available. While many companies were trying to understand artificial intelligence, NVIDIA was already prepared. It had spent almost 20 years developing increasingly powerful chips, investing in software, and building a complete ecosystem for researchers and developers. When demand finally exploded, NVIDIA did not have to start from zero. It was already years ahead. Within months, almost every major technology company announced billions of dollars in artificial intelligence investments. New data centers began appearing around the world. Companies competed for engineers, infrastructure, and most importantly, GPUs. For the first time, computing power became a strategic resource, something comparable to oil during the Industrial Revolution. The companies with access to the most computational power would have an advantage in building the future. Demand for GPUs grew so quickly that NVIDIA simply could not manufacture enough chips. Companies waited months to receive their orders. Some were willing to pay far above official prices just to secure priority. For the first time in history, graphics cards stopped being just products for gamers. They became critical infrastructure for artificial intelligence. For years, many investors saw NVIDIA as a cyclical company dependent on the gaming market. But as financial results started being released, that perception completely changed. Revenue, profit, margins. Everything was growing at a pace rarely seen in the history of the stock market. What was once considered a hardware company became something much bigger. NVIDIA became the company selling the tools during the artificial intelligence gold rush. Just like companies that sold equipment during the California gold rush made fortunes supplying the miners, hospitals training AI systems to detect diseases, autonomous vehicles learning how to drive, robots making decisions in real time, researchers discovering new medicines, satellites analyzing climate change. Behind almost every one of these applications, there is one common element: computational power. And during this new technological revolution, few companies controlled as much of it as NVIDIA. Jensen Huang spent decades defending a vision that many people considered unrealistic. While the market searched for immediate results, he invested in technology whose true potential would only appear years later. When artificial intelligence finally exploded, NVIDIA did not need to chase the opportunity. It simply collected the rewards of what it had planted decades earlier. However, controlling an industry as important as artificial intelligence also brings new challenges. Governments began imposing restrictions on chip exports. Competitors started investing billions of dollars to reduce their dependence on NVIDIA. And companies like AMD, Intel, Google, Amazon, and Microsoft began developing their own solutions to compete in the future of artificial intelligence. The question was no longer, how did NVIDIA build this empire? The real question became, can it maintain it? For most of the 20th century, oil was considered the most strategic resource on Earth. Whoever controlled energy had enormous influence over entire economies. But in the 21st century, a new resource began competing for that position: computational power. Without it, there is no artificial intelligence. No autonomous vehicles, no advanced medical discoveries, no large-scale AI models. And few companies controlled as much computational power as NVIDIA. In just a few years, NVIDIA went from selling components for personal computers to providing the infrastructure behind governments, universities, research laboratories, and nearly every major technology company in the world. But this level of concentration created an important question. What happens when a single company becomes essential to an entire industry? While American companies accelerated their investments in artificial intelligence, another country was watching closely: China. The Chinese government understood that controlling artificial intelligence could mean controlling the next generation of the global economy. The problem was that the most advanced chips were being produced by American companies. As geopolitical tensions increased, the United States began restricting the export of NVIDIA's most advanced chips to certain markets. The official reason was national security. But in practice, semiconductors became a powerful tool in international politics. The world's largest companies realized that depending on a single supplier created a massive risk. So a new race began, building their own chips, Google invested heavily in its tensor processing units, known as TPUs. Amazon developed its own AI chips, including Trainium and Inferentia. Microsoft began creating its Maya processors. Even companies that had never manufactured chips before decided to enter the competition. Building a powerful chip is extremely difficult. But building an entire ecosystem is much harder. It is not enough to create hardware. A company needs developer tools, optimized libraries, documentation, support, and years of refinement. That is exactly what NVIDIA created with CUDA, starting in 2006, and this may be its greatest advantage today. While new competitors tried to catch up, the artificial intelligence market continued accelerating. AI models were becoming larger every few months. The cost of training these systems increased exponentially. And the more powerful these models became, the greater the world's dependence on NVIDIA's most advanced GPUs. Jensen Huang was no longer just a CEO. He became one of the most influential figures in the technology industry. Every presentation announcing a new NVIDIA chip was followed by investors, governments, and companies around the world. In only a few years, NVIDIA's conferences started looking less like product launches and more like global technology events. Thousands of people watched every announcement. Markets reacted instantly, and entire industries waited to see what NVIDIA would create next. But the next major battle may not be only about artificial intelligence. It may be about energy. The most advanced data centers already consume enormous amounts of electricity. As AI models continue growing, the challenge is no longer only producing better chips. The world will also need enough energy to power millions of them simultaneously. NVIDIA won the first major race of artificial intelligence, but every leader creates competitors. The real question now is, are we witnessing the birth of the next technological empire in history, or the beginning of the greatest battle for computational power the world has ever seen? For decades, oil companies dominated the global economy. Then came banks, then internet giants. But for the first time in history, a semiconductor company reached the top of the market. Not because it sold computers, but because it sold the most important ingredient needed to build artificial intelligence. When investors finally understood this, NVIDIA stopped being seen as a hardware company. It became the foundation upon which the new economy was being built. History shows that no company remains on top forever. IBM once seemed unstoppable. Nokia dominated mobile phones. Intel controlled processors. Kodak led photography. All of them believed they possessed advantages that could never be defeated. All of them discovered the same truth: innovation never stops. The same artificial intelligence that helped NVIDIA rise could one day create technologies capable of replacing its own GPUs. That is the nature of technology. Today's leader is always at risk of becoming tomorrow's forgotten giant. During the Cold War, nations competed to see who would reach space first. Today, the competition is for something potentially even more valuable: computational power. The countries that dominate artificial intelligence will have economic, scientific, and military advantages for decades. That is why this competition is no longer just between companies. It now involves governments, universities, chip manufacturers, and some of the world's largest economies. While this video was being created, thousands of new artificial intelligence models were being trained. New medicines were being discovered. Robots were learning new abilities. Autonomous vehicles were driving millions of virtual miles. And all of this was happening silently inside. Data centers spread across the world. The artificial intelligence revolution is not coming. It has already started, and we are living through the very beginning of this transformation. When Jensen Huang founded NVIDIA in 1993, his goal was simple: create better graphics processors. He could never have imagined that, 30 years later, his company would become one of the most important forces behind one of the greatest technological revolutions in human history. But perhaps that was never his true advantage. His greatest skill was believing in a future that did not exist yet. while everyone else was trying to solve the problems of the present. He was building the infrastructure of tomorrow, maybe 20 years from now. We will look back at this moment the same way we look at the birth of the internet today, the moment when everything began. The real question is not whether artificial intelligence will transform the world. It already is. The real question is, who will control that transformation? The story of NVIDIA proves that the biggest companies in the world rarely win because they understand the present. They win because they can see decades into the future. That is what transformed a small graphics card company into one of the most important technology companies in history. And if there is one lesson from NVIDIA's journey, it may be this. The biggest revolutions almost always begin long before the rest of the world realizes they have already started. Artificial intelligence is changing the world faster than almost any technology in human history. And this is only one of the many stories behind this revolution. If you want to understand how companies, technology, and strategic decisions shape the future, subscribe to the channel. Because the next major transformation may already be happening right now.